So as Olivier said, I will show you how to connect to the cluster using SSH. First, a little introduction. SSH stands for secure share, and it's a way to transfer data and communication between two computers in an encrypted way. Like this, nobody can see what you are sending over the network. So let's say that you are user 1 on host 1 and want to connect to user as user 2 in host 2. The host 1 is called the client, and to connect, you need to install Open SSH client on your computer. But for Linux and macOS, this program is already installed. In the server, you need to install Open SSH server, as the server is always listed on port 22 and waiting for a connection from clients. There is two ways to authenticate as user 1 to connect to the host 2 as user 2. First is to know the password of user 2, or to use a identity file called private and public keys that identify you. Also, this can identify the server. So the public key is used to encrypt data, which is only decrypted by the private key of the users. To let the server or the user know that you are the good person, the good user, he needs to have the public key of user 1. And the client must know also that he's connecting to the good server. For this, he needs the public key of the host. So I will show you an example here. I am user 1 in host 1 and want to connect to host 2 as user 2. So I type this command, SSH user 2 at host 2. The first time I will receive the public key of the host 2. So I can accept the key if I'm sure that I'm connecting to the good computer. Then I'm asked for the password of user 2. And now I'm connected to user 2 on host 2. So this is the first way to connect in server 2, is using the password of the user. Now I can create a pair of public and private keys with the command SSH keygen. This will create by default a file ID RSA inside SSH folder. Now I have to put a passphrase to encrypt my private key. This prevents if somebody stole my private key, he cannot use it as it's encrypted and cannot use it to connect in your name. So if I show now, I have a new file with my private key, which is encrypted. So you need the passphrase to decrypt it, and also a public key, which is related to this private key. So everything that is encrypted with this key or this file is only decrypted by my private key. So now what I can do is to send my file, my public key, to the host 2. For this, I use the SSH copy ID. I select the key I want to send. So I will send my public key here to user 2 at host 2. So as you see here, the source of keys will be installed is my public key here. And now I type the password of user2 on host2. And now I can connect with my private key to the host2 as user2, because now user2 has my public key, so now he can know if I am user1 or not. So now, instead of the passphrase of the password of user2, I need to type the passphrase to decrypt my key. And as you see now, I am in a host2 as user2 again. Oops. There is a question. I should reply now or just follow? Okay. So this is like an introduction how SSH works on Linux and macOS. Now I show you where this SSH is used to connect to the clusters. So for this, I show you how the SSH clusters are composed. They are, we have in the SSH 5 cluster from 5 French-speaking universities. They are a stack of storage and compute nodes. So some computers here use it for storage your data, to save your data or to compute your code. And there is also a tier 1 facility or tier 1 cluster, which is bigger, that can be used by SSH users under special conditions. All those nodes, compute nodes, and storage nodes are connected between them with a private line or private network. You can see an example of the stack of compute nodes on the net 3. And in the back of Dragon 2, you can see all the connection for the network between all the compute nodes. Now, to connect to the cluster, you go through a front end. Here, each cluster has a front end with the name of the cluster. So this computer, this front end, is used to submit your jobs to the compute nodes, access to the results when they finish the computations, edit your files, compile your code and debug it, or transfer your data between clusters or between your computer and the front end. So do not run heavy jobs on the front end, as you will penalize the other users, and it's not the front end is not done for running jobs. You need to submit your jobs on the cluster. Those front ends are behind a firewall that prevents connection from any computer except a gateway of the university. So those are the gateway from each university, and the user from UCL20 should connect through the gateway of UCL20 for ULEG and so on. And here is where you use SSH. So you connect to the gateway or to the front end through the gateway using SSH. And now I show you. So this is the list of different front ends. You have to choose the cluster that you want to use for calculation. Here there is a mistake. It's not NIC4 but NIC5. NIC4 is not available anymore, and Vega is not available anymore. To choose the gateway, you have to choose the one from your university. So to connect to the front end, you need to have a private key. So to get the private key, you have to go to this link, fill the form here, and send to receive an email with a link to a form. So this will generate, after receiving the mail to the form and filling the form, you will receive a private key. It's a file called id.rsa.cc relate to a public key, id.rsa.ccp. This private key, you have to save it in a secure place, and you will see that it's encrypted with the passphrase that you will put when you fill the form during the registration. Here, you must know that CC does not keep a copy of your private key for security reasons. So if you lose the key or the passphrase, or you think that somebody stole your key, you have to renew your account at the same link that before. But this time you choose renew my account instead of create account. So the private key is sent to you, and the public key is put in every front end and every gateway. Like this, it can identify you when you try to connect to the cluster. Also, every front end and gateway has its own private and public key. Like this, you can identify the computer where you are connecting. You will receive, at the first connection, you will receive the public key of each, first of the gateway, and then of each front end if you use one of the clusters. So the first exercise is to get the key, the private key for those who doesn't have one. Like this, we can continue the rest of the presentation. So if everybody has his private key, it's okay, but you have to be sure that everybody can connect to the cluster. So the step is go to the CC website, click on create manage account. You get to this form, fill your email and send to ask for the creation of your account or the renewal of your account. Then you will receive an email like this with a link. This link sends you to a form. You have to fill the form with your information, your name, a login. Use a login that is something with your name or first name or your last name. Your supervisor email and an affiliation. When you have filled also, don't forget to put a passphrase to encrypt your private key. When everything is filled, you can send the form. Then sysadmin will receive your will receive your form, and then will validate your inscription. In this case, you will receive an email like this with your private key. So we need to be sure that everybody has a key. It's here, everybody has a key. And Zoom. Is you are asking answering the questions, or I have to answer?
I will answer. I asked in the chat is everyone the checkup, and you said you can.
Okay, I can go. So when you have your key, you have to create a .ssh directory if you don't have it already. Change its permission to read only for you, and move your IDRs, your private key or identity file to this folder. Change the permission of your private key to be sure that only you can access. So when you do ls-l of your SSH identity file, there is only read-write for the user. And the same for the folder is only read-write and the X4 you can enter in the folder. You can also create your related public key using this command, SSH keygen -I to create the public key from your private key. This could be useful if your key ring use the public key to store the passphrase in memory. We will see this later. Now you have your private key in a good place. Go to this link to fill a wizard that will create for you the configuration file to connect to the clusters. So you choose your university, your login that you put when you subscribe to the SSH. And like in UNamur, you need to put your UNamur ID that normally should be the same that you put in the SSH form. The form is different depending on your university. So once you have filled this, you can copy this and create a file .ssh/config in your .ssh folder. So what you have is the address of the gateway. Here is the UNamur gateway. And every connection to the front ends here, there are the 5 front ends, go through the gateway SSH. Here, proxy jump means that have to go through the gateway SSH to connect. And here the list of each front end where you can connect. So this is the file that you need to have inside the SSH folder. And the next exercise is to do the first connection. So once you have this file and your your private key here. You can do SSH host, where you change host by one of the front end here, Element 3, Hercules, Dragon 1, 2, or Nick 5. And then you can connect to the front end. So you can go here, you do something like SSH. And then I'm connected to Hercules. Or choose another front end. And then I'm connected to Element. If it is your first time you connect, you will receive the public key of the gateway and the public key of the front end you are trying to connect. So you have to compare it. If you want to be sure that you are connecting to the good computers, you have to compare to each cluster has its own public key here. And so on. You will be asked also for the passphrase. I am using an agent, so when I connect to the cluster, I don't have to type the passphrase, but I will show you how to do that later. So here, the first thing is to connect to one of the front end, and if it is Element 3, you can try to test if the forward X11 configuration works. This means that you can open a remote window on your computer. For macOS, you have to install Xquarks, and be careful because when you install, you need to reboot your computer. So normally you should have so when you run Xeyes, you have this little window which appears. This means that X forward is working. You can stop with Control-C. So did everybody could connect to Element 3 and open Xeyes? Est-ce que ça va ici? It's okay ici? Yeah. Okay. So now if you don't want to type your passphrase every time you connect, you can use an agent. Normally in Linux, like with Mint, you have GNOME Keyring, or you have KDE Wallet, or for macOS also, you have one agent. And as I said before, if you use GNOME Keyring, you need to have also the public key of your related to your private key. If not, it's not going to put it in memory. For macOS, you need to have this configuration in your .ssh config file to use the agent. To test if your agent is working, you can type this command. So if I do SSH -L, I have my keys in memory here. But you don't have, if your agent is not running, you have this message. And if it is running, but there is no keys or identities in the memory, so you have this answer. You have, it is working and with keys, so you have something like that. To start your agent, you type this command, eval SSH agent, and start to add the keys in memory. So here you will type the passphrase once, and then the identity will be added, so you don't need to type the passphrase anymore. And then you can check that your identity is in the memory. Some frequent mistakes that you can do is to have bad permissions on your key file. So you will have this message, bad permission. The solution is to change the permission with chmod 600 of your file. Another error that you can have is you're asking for the password instead of the passphrase. This means that the key is not the good one, or is not correctly addressed here in the identity file configuration, or it is missing inside the .ssh, or your account is spam. Another error is that here the key has been decrypted by is asking you still for a user password. So this means that the user is not good. So you have to check if the user is here. Or also, if you have changed your private key, you have to wait more or less 30 minutes that the keys are in all the front end. In any case, if you have a problem, you can also use the -v or VV or VVV options to debug your session. So you can see that here you agree that you find the good private key of the gateway inside your host. Then you are the gateway has authenticated you. The same for the front end. You authenticate the front end with this public key, and then here is the front end that has authenticated you with your public key. You can also use SSH-based programs or tools to transfer files. So they use the SSH protocol to transfer the files. The first one is ECP command. You can copy folders and files to the front end or from the front end. So here you can you have an example. You can create a folder with 4 files. So SSH. So first I created the directory, then with touch I create 4 files. And here you can see I can execute commands in the front end without connecting to a terminal or to get a terminal inside in the front end. So if I make SSH, let's say the method tree and do the command kd I will create a directory cour SSH in a elementary tree frontend. So I can check if this directory exists now in the front end. Now I can copy this directory. The folder scp test to the method tree. Oops. Inside the folder in the remote host. It is a directory, so I have to put -r for recursive. So we can check again. And my files are on the front end. Oops. You can also copy from the front end to your computer, just doing the reverse command. So you can copy cour scp test. So I will copy now scp test folder to my computer. and the SCP test is here now. If you want to copy between front ends, it is not permitted because the firewall does allow you that. So use the SSH transfer partition. So you can follow this link and you get information about SSH transfer partition. It's a partition when you connect to any cluster. So you have a SSH transfer here, and you can create a folder with your identity, your AID, and copy your files inside. And this folder is common to all clusters. Okay. So instead of putting things on the root of this folder, better if you create a folder with your name and transfer files inside. So if you connect to another cluster, you can see here in Hercules, you have the same files too. Other way to do it is using the option -3. This will copy files from one front end to your computer, and then from your computer to the front end too. So it's slower, because it needs to go one way and then to the other. The next program you can use to copy files is Rsync, which is used for backup or mirroring your data. It's better. It's more powerful than ECB because it's only transferred the modifications. The file has not been modified, but it will not transfer. You can use the option -R for archive and the option Z to compress data, so go faster through the internet. So here you have the same kind of exercise that you can do, but this time with Rsync. You can put -- progress to see what is going on, and UV for variables. So we can create now an Hercules. So we have to leave. And then copy it with Rsync. Achieve, variables, compress, - progress from, oops, no. Oh, sorry. What I did here is to create, I created the folder on one front end, not on local one. So let's do it. So now the folder Rsync test is on Lemaitre 3, and I want to copy it on my computer. So I use Rsync minus archive verbose compress minus progress from Lemaitre. So I have to remove the backslash, and I want to copy it on cours here in this folder, cours SSH. Now I can modify one file here on the remote host, so in the front end. And do again Rsync. And you see only file 1 has been transferred because it's the only one who has changed. So you can do the same thing from your computer if you change something in your computer. You see, now I have put test here, but I want to keep this modification even if I get the data from the remote. So I have to put the U option. So if I put minus U, all my local modification will be you see, I have, there is nothing who has been transferred, and my file is still as a content test. If I remove this, the contents will be synchronized. Or my local modification will be removed. The other option is the minus delete, del, sorry. If you want to delete a file at the front ends, and then you want to delete it also in your local computer. So let's come back to here the Lemaitre 3 connection. So let's say I will remove file 1. on elementary 3, I remove file 1, and then if I do, so now it's not there. It's not in the elementary 3. So now I can do again the command with --d. And now file 1 is deleted. So this is to the use for how to use Rsync. The last tool that you can use is SSHFS. This is used to mount a remote file in your computer. So you can mount a remote folder in your computer and work like if you are in your computer in a local folder. You can install it in Ubuntu with apt-get install, or in CentOS or Fedora with Yum, or in macOS you need to install Fuse and SSHFS from this link. So to use it is you have to first create a directory where to mount the remote folder. Then type this command. First, create a variable called cluster equal to one of the from 10. Okay. And then start with SSHFS. So first put the UI user ID. So I type SSHFS, I set the user and group IDs. Here will be replaced by the cluster name, the variable here and here. And this will mount my CC home on elementary 3 folder. Okay, now I can do ls elementary 3. And I have the contents of what is in elementary 3. So if I do SSH elementary 3, and here I do ls, I have the same contents than here. To mount your folder, here you do fuse mount. No, sorry, fuse mount -u of the folder. And then if I check what is inside, there is nothing. The folder has been mounted. You want to have more information about SSH, you have 3 links with the protocol and things about SSH that you can read. You want to have more details about how SSH works.